Hello again and welcome to the 6th module in our series about teaching maths in the FET phase, that is grades 10, 11 and 12. This series is aimed at maths teachers in the FET phase and everyone else who's interested in maths education in South Africa. Let's first start by taking a look at our video.
When I as a person heard about linear programming, I associated it with the word linear and programming. Linear meaning straight and programming means as in a computer program, but it's far from that. Linear programming is actually utilizing linear forms to solve many real-life problems.
One of the advantages of linear programming as a topic is that it can be used to solve problems that are within the everyday experience of learners. Take the issue of organizing transport for school outings. Both learners in urban and rural areas have probably had some experience of school visits, and today's lesson deals with a trip to a sports meeting. Teacher Ace Mpakalasi is working with a small class of higher grade learners at Mshukantambo Secondary School in Soweto. The teacher first poses the problem.
We have a problem here. There is a school, let's say it's Mafunda High School, which needs to transport about 4 soccer teams and 3 netball teams to take part in a tournament in KwaZulu-Natal.
The aim is to transport these 7 teams to the meeting and achieve this objective at minimum cost.
Team members, including reserves.
There are also a number of constraints. At most, 3 small buses and 4 big buses are available. At least one of each type of bus must be used. There are a maximum of 5 drivers available to drive the buses. Each small bus can carry up to 30 passengers. Each big bus can carry up to 60 passengers. During the first part of the lesson, the learners identify what combinations of big and small buses offer possible solutions to the problem. They go through a table of possible combinations, marking which ones are possible and which impossible.
You've got number of drivers, okay, 5 drivers.
There isn't any.
And you've got 4 small buses and 3 big ones. The total is 7 and you've got 5. So 2 buses are going to be short of a driver. So it's no.
It's not possible.
Yeah.
Where necessary, the teacher guides the learners to ensure they are observing all the conditions required.
Now let me ask you a question, another question. When you say 4 and 0 is correct, why do you say that?
So they have a maximum of 5 drivers. So let's say for buses X is X plus Y. Should be less than 5.
Okay. Just go through the conditions given to you here. Go to the next page and try to plot all those possible combinations on the grid that you have.
2 and 2.
4 and 1 years.
Yeah. Then you have 3 and 2.
3 and 2 years.
The teacher then checks that all the groups have the same result.
So the only difference is you don't have, why don't you have 1 and 1?
The number of team members must be at least 113. So if you take the type of...
The group members point out that 1 small bus and 1 large bus can only carry 90 team members at most, not the minimum of 113 required.
I'm saying, they're saying here, there will be at least 113 members, team members.
Yeah.
So I think we should use the greater or equal to sign. So,
and I think we should use the smaller than or equal sign, because when they're saying at least, it means it's either that or less than that. So the smaller than sign.
if I explain it,
As a second learner shows, one of the most common problems for learners working with linear programming is failing to understand the frequently used phrases. If they do not understand these phrases, they will not be able to express them in mathematical form.
There are certain phrases that are very common in linear programming. For example, phrases like, you must have at least, or there must be at most. Now, those kinds of concepts might sound easy to you and I, but For the majority of learners, it is not easy. I can cite a simple example for you. On the freeways, we have two speed limits. One is around 20 or 40 and the other one is around 120. And those can be used as examples of what it means when we say at least and at most.
I always explain most means the maximum. So if you have maximum, you cannot go beyond the maximum. Least means the minimum. If you have the minimum, you cannot go below the minimum. You can only go above that. You can only go below the most and above the minimum.
To highlight the language issue, the teacher deviates from the main bus problem at this point and gives the learners an activity that focuses on language.
Here are statements next to that, on the left-hand side. I want you to read those statements and try to change them or choose from the right-hand side which relationships best suits the conditions.
The statements include, they can produce at most 30 desks, the school won't allow him to take more than 9 subjects, there must be at least 50 car bays. The learners work through the questions in their groups.
At least X, yeah. X is greater than 4.
I can see that you are using numbers, the actual numbers. I wanted to look at the relationships there and associate them with the statements here. That should be easy because you have already used numbers.
The algebraic statements help the learners become more comfortable with thinking abstractly about relationships of equality and inequality.
We say in number A here, he must do at least 5 subjects. What is the mathematical statement for that?
X should be greater than or equals to A.
The teacher works through the other statements with the class and then returns to the main question concerning the buses.
To A.
You found the combination of buses and tried to plot them, okay? Now I want us to find constraints, the inequalities.
They say there will be at least 113 team members, including reserves. So I was saying X plus Y should be greater or equals to 113.
Let me give you a hint here. Does X stand for the number of learners or the members of the team, or does X stand for the number of the transportation buses?
I don't think Munsu is necessarily correct because X and Y, they are standing for transport, whilst 113 teams should be humans.
The teacher reminds the learners one trainer for each of the 7 teams must be included, bringing the total number of passengers up to 120. The learner then formulates the inequality correctly by having both sides refer to the number of passengers. The teacher then formulates the other inequalities together with the learners. The fact that there must not be more than 5 buses used.
X smaller buses plus Y bigger buses less than 5. Less than or equals to 5.
The requirement that at least one of each type of bus must be used.
Y big buses is greater than or equals to Y. And X is greater or equals to Y.
If we put X equals to 1 and Y equals to 1, we're going to get 90, which is the incorrect part. I think Y is greater than 1 and X is greater than 1.
The combination Y is equal to 1 and X is equal to 1 may not be possible, okay? But the combination may be possible.
Then the constraint that at most 3 small buses and 4 big buses may be used.
Small buses less than or equals to 3, Y big buses less than or equals to 4.
I'm going to highlight or show you the skills of plotting all these inequalities on a Cartesian plane. Okay? Now, what is the minimum value of y? 1. Y is equal to 1 is the minimum value. Therefore, I'm going to try to draw the line y is equal to 1. From experience, when you draw this, what type of a line is this going to be?
It's a horizontal solid line.
Is that all?
It's a horizontal line and we include 1 at the y-axis.
So now look at this line here. Y is equal to 1. It has divided our Cartesian plane into two parts, the upper part and the lower part. Our value is going to be in the lower part or in the upper part.
He emphasizes that the solid line at the boundary of the area denotes that the values on the line are included in the feasibility area.
My solution to this.
The teacher then proceeds to work through the other inequalities with the learners, drawing the lines that denote the boundaries of the area.
I think it's going to be a vertical line passing through the x-axis at 1.
The teacher draws the line.
And
a vertical solid line passing through x is equal to 3.
Okay.
You'll draw the horizontal solid line that passes through y equals to 4.
Y is equal to 4.
The teacher then moves on to the more complex inequations.
Let's look at that part. To draw this part, we need to use the dual intercept method. Find the x-intercepts, find the y-intercepts. Okay? Now, to find the x-intercepts, we make the value of y to be 0. In short, you cover up that, and you are left with the x-intercept.
The teacher similarly calculates the y-intercept and then joins the 2 points. He and the learners then decide the possible solutions lie below this line.
Y is equal to 2.
Using the same dual intercept method, the teacher then draws the line representing the final equation. 30x plus 60y is greater than or equal to 120.
Where do you plot? Above or below? Above. Now, look here. Here we are looking for a region that is going to satisfy all the pointers that we have made. Do you understand? Now check this. This region does not satisfy this line, this point. Already this region falls out.
The teacher works through all the areas that can be eliminated. At the end, he's left with the feasibility region, which he shades in. All the possible solutions to the problem lie within this region.
This is for clarity. You don't need to do what I'm doing. Now, in every problem, we have an aim. They say here, if the cost of hiring a small bus is 500 rands per day, and the cost of hiring a big bus is 800 per day, what is the cheapest solution to the bus problem above? Now, remember that we have a multiple of combinations, which are solutions.
It has now come to the point where the learners need to establish the objective function to determine the cheapest solution to the bus problem.
Objective function. Objective function allows us to choose the best solution.
Given the cost of the smaller buses as 500 Rand per bus and the larger buses as 800 Rand per bus, the cost of the trip is given by 500x plus 800y. The next step is to put the equation into the form of y equals mx plus c.
Plus c. Now let's change that. This becomes y.
Y is equal to minus 5 all over 8x plus c all over 800.
That is what you have. But look at this. This is a constant. This number is a numerical value that we know, or that can be calculated. That is a constant. The whole thing becomes a constant. Therefore, I can reduce that to one letter. Do you understand? Then this is the same format as that. How does this line slope? Does it go down this way or down this way? The first one, this, what gives you that idea? The negative.
By using the linear intercept method, the teacher can show the gradient of -5/8 on the graph.
Slide it down this way. I touch that first, then that one, then that one, then this one. The last point to be touched here will be C. So I'll say here, C is the point 2 and 1. Okay? And when I interpret C, C is the point that is going to give me my minimum cost.
Thus, the minimum cost is achieved with 2 small buses and 1 big bus. Together with the class, the teacher checks that the solution they have reached complies with all the constraints. This arrangement allows the buses to carry 120 passengers as required.
Teachers should not concentrate on the product or the final answer to the question. Because if a learner, for whatever reason, considers any constraint incorrectly, then you do understand that that would influence the whole solution to the problem. So what I am saying is, let us rather assess the process in arriving at the answer.
Now that we've seen the video, let's welcome our guests for this session. Maggie Verster, Independent Maths Consultant, another Independent Maths Consultant, Catherine Hunter, and Edward Musegi from NGO Protec. Thank you for joining us. First question to you, Maggie. What is the value of linear programming as a topic for learners?
One thing that I feel strongly about as far as linear programming is concerned, to actually, from the start, tell the learners that this is a way that you can solve real life problems. Think of a problem in your life. You're dating. I can only date 2 guys and I've got to be in by 10. Think of real things that's happening in your life so that they can see, okay, well, this is not just this word constraints. This is real. I can only date 2 boys and the boys can only date 2 girls, and sort of bring it back to real life and allow them to create their own little linear programming problem. And that way it becomes more real for them.
Catherine?
That's certainly a lot of it. I would agree with you. The beauty of maths really kicks in at this subject, in that learners have to consider and understand a real-life context, consider a variety of viewpoints on it, and put them all together. And they can see it diagrammatically, they can see it visually, and they can come to a conclusion. They can find an answer to a real problem situation. It's very useful.
As we saw in the lesson, terminology can be a problem for the learners. How can teachers overcome this?
I think that this teacher used a very novel and interesting way. He stopped the maths lesson, if you like, and stepped aside and used it as a literacy opportunity. So he went off at a tangent, and he gave the learners the opportunity to explore the language. In this case, it was what does it mean to be at least or at most, and brought in the language issues, which in a way flags for learners the fact that, watch out, I mustn't assume that I understand what this means. And he went into that at depth.
Maggie?
Our learners have to come to grips with terminology, and I think as teachers we must be very aware and we must make it fun. We must actually take terminology and change it into fun, like the teacher did. Think of real life fun ways in which you can think of maximum, minimum, at least, the question of and or. Just put the terminology in real terms that they can have something that they can hang on to.
Is confusion about what variables stand for a common problem for learners? And how should teachers deal with it?
Yeah, it is a big problem in that if you look, for instance, at what was happening in the videos, we had 2 teams. Those are 2 variables. We had 2 types of transports or 2 types of buses. That is also a variable. Now, the challenge is for the learners to select which variables are more relevant to the problem. And how do you do that? You ask learners leading questions and let them read through the question. Let them try to define what are their own variables. And then if they still have a problem, let them lead them through the exercise themselves instead of telling them. And it is very critical that the variables are defined clearly at the beginning.
Catherine, you agree?
I agree, and I think a lot of the problem facing teachers is how to pace themselves. Because in a complicated problem like this, where there are many different variables, well, there weren't many different variables, but I think there were 5 different inequalities that the learners had to understand and then graph, and it was a combination of those 5 inequalities that led to the solution. The teacher really needs to give them sufficient time to be able to discuss amongst themselves what the meaning is and what the significance is of each of those different variables, different inequalities. Maggie?
Choosing those variables is very hard for the learners. I actually find giving them a problem where they have got to figure out what variables to use and when is hell. So I actually think sort of maybe an approach to take with helping them as far as variables is concerned is to make up their own little problems and allocate variables. And that way they can see the variables is not something terrible, it's something that's relating to the problem and the constraints that they're using. So sort of allow them to make it their own.
Okay. Edward, what other problem areas are there in teaching linear programming?
One critical problem area is learners being able to identify between the discrete and continuous variables. I'm looking at an issue of a person. You cannot transport half a person because they also impact on the type of graphs that you're going to draw.
Catherine?
I think one of the main problems of linear programming is that it tends to be quite overwhelming. There's so many factors that have to be taken into account, and there are the constraints. And the chances of a learner missing one of the constraints, or at least underestimating the significance of a constraint, or reading over some important factual information are quite high. The chances of that are very high. And so, and as we saw in the video, the teacher had to go around and check that in fact everything had been considered. Because if all those factors are not taken into consideration at the very early stage of the problem-solving process, then putting it into inequalities, putting it onto a graph and so on is not going to happen accurately. And I would absolutely agree with the commentator at the very end of the video that we have to work out how to assess the process and not necessarily the end result, and give learners credit where it's due throughout the process. And that's the main support the teacher can give.
One of the problems that I also find comes up with linear programming is that sometimes the learners have struggles to actually draw the graph. So there we have to take them back, like the teacher did with terminology, actually take them back to drawing straight lines and just get back into straight lines. The second thing is the language. I find that learners, when they look at this linear programming problem that you give them, they just see words. And immediately this is a word problem and I don't want to attempt it. Whereas if they look at it in little pieces and they actually see, but this is just a small part of a linear problem that I can get out quickly, then I'll be fine. And of course, the bigger and smaller than signs, it's a problem everywhere. I call them crocodile bites and they eat you. To actually understand the difference between bigger than and smaller than sign, and I really adored the way that the teacher sort of made that quite clear and real for them.
Well, thank you very much. Thank you for joining us. That brings us to the end of this session. Please do join us again when we look at Module 7. Thank you for joining us. Goodbye.